My name is Paul, and I'm presenting on nonlinear process monitoring based on a global preserving unsupervised kernel extreme learning machine. So, unsupervised extreme learning machine technique as a nonlinear data mining approach has been employed to diagnose nonlinear process faults. This is mainly in industries, but during the dimensional reduction of the process observation, the data UELM only aims at mining the local structure feature information of the process data and lacks the ability to preserving the global structure analyzing of the process data, which would perform unsatisfactorily for monitoring linear processes. The goal of ULM is to ensure the closer samples in the original data set are similar to the prediction and corresponding to these two samples in the output space of the output layer. Now, the determination of the optimal optimal UELM model UELM hidden node numbers is a tough issue. Now, i.e., the number of hidden nodes of a layer, the ULM should be determined beforehand, which is extremely time-consuming. ULM can be defined as a special type local structure preserving technology because it only considers the neighborhood relationship between the different samples in the original data set. So what solution is this paper proposing? So what paper is proposing is to introduce a global structure and analysis technique into the ELM to adopting the kernel trick to tackle the challenges and determining the number of hidden layer nodes. The optimization layer will capture both the local feature and then the global feature structure of the information of a data set. And how is it going to achieve this? By using the kernel trick, by applying a generalized agent value decomposition, the kernel, and then also in order to monitor the low dimensional feature information derived from the GUK ELM, it is going to be employed to compute the static to the SPVD to detect the fault based on the distribution of the training data. Now, simulation results obtained from the numerical process and then the benchmark continuous steering, which is a CSTR process, verify the feasibility and effectiveness of the developed monitoring model. Now, for the UELM algorithm, for the unsupervised ELM is built on the basis of the principle that if the data point xi and xj are neighbor positions in the space, then the value of the conditional probability of py given x and then y given j xj must be similar to each other as well. In order to satisfy the above principle, the manifold regularization framework is employed in the equation, this equation here, where w, I, and j represent the weight parameter. Inflict a big penalty if the large variant occurs for the probability of y given xi and y given xj of the two neighboring points, that is xi and xj. In the ELM, standard ELM benefits from the manifold regulation principle to make use of the unlabeled data, and when labeled data is not available by the means of recomposing the original ELM optimization objective. Optimization objective function for the standard ELM is shown by this one, that is equation 11, where the matrix L is constructed depending on the unlabeled data set, and then the lambda is the trade-off parameter, and matrix F denotes the network output, and then F1, and then is the ith row of the matrix F. Then the new proposed algorithm method is proposed to imposing So we're imposing the global structure analysis onto the original UELM algorithm. After projecting the neighboring samples, the neighbor samples are still, of course, they are still in the latent space, they're still close by, and the distant samples are still far away. Besides, when the tackling the nonlinear characteristic of the process model, the kernel trick is utilized in the ULM method to handle the tough issue of choosing the number of hidden nodes. Yes. And for the global preserving UELM, now we're now imposing it on the UELM. We have a data set, yes, of X number of items. The global structure analysis technique is integrated into the ULM method to seek the output weight, which is matrix beta, yes, which is a union of R, like you can see in the equation where, which guarantees the mean square of the Euclidean distance, yes, among the output points, and is maximized. Yes, so we have the global. Now these are data points that are away, or they are further away from from the neighbor that was chosen by the UELM model. Yes, so if we assume that h is tending to 0, where hx and denotes the output vector relative to xi, it is reduced to the global. Remember, we said that global matrix B, and comes to this equation where h denotes the nonlinear feature mapping matrix defined in the equation 3 that we saw earlier. To overcome the issue of explicitly choosing the optimal number of hidden layer nodes, in GUELM method, the kernel trick is employed in GUELM method by applying the kernel function, which is this one here. A kernel matrix K of a global preserving and supervised kernel ELM is computed. And we have the vector that we're going to use for the kernel matrix. So the kernel function employed in the GUELM is chosen by the Gaussian kernel, and then which is what you saw here. Yes, where K the parameter which can be determined by the user, then the biased and then based on the defined kernel matrix K, the generalized agent composition problem can be expressed as this one here. Okay, so fault detection strategy based on the GUELM method, the SVVD has gained greater attention in research for this process monitoring, outlier detection, and then one-class classification. Yes. So now for this particular case study, we have the offline modeling, and then we also have the online modeling. Now the offline modeling, we collect a normal operating data set X and normalize it, then construct a matrix W and D and L, and then build the ULM model. Build the GUI model by combining the global structure and then the analysis and global structure analysis and the kernel trick. Calculate the confidence limits of the monitoring statistics based on SVVT. Obtain a new now for the online detection, obtain a new observation data, to the data set, and of course we scale it. Yes, then compute the test kernel vector the pin center, and then calculate the static vector D by using the SVVD to project the vector I. In monitoring statistic, D will exceed the, so once it exceeds the confidence limit, a fault is detected. Yes. Yes. Now for the first one, this is the table. We have a fault detection times, and then the fault detection rates, FDR of the 3 methods that were put in. And from this one, we realize that the GUK ELMD static is the highest among the 3 methods. To be specific, it is at 96 point. So that means that it has superior performance as compared to this and then the UELM methods. Yes, now the next case study is where we are going to use this one for the CSTR process that is illustrated as below. So these are the faults. As you can see, these are the faults, and then these are the descriptions for each of the faults that we are going to be using for the simulated 7 fault pattern for the CSTR process. So okay. So the proposed KU-based monitoring scheme obtains a much faster fault tolerant detection time for KP, and based on the methods, these troublesome ramps, the average fault detection for the rates further manifest the effectiveness of the performance of this model that has been suggested in this paper, like you can see here, and then also for this one here. Yes. The fault detection percentage for the three models, this one, and then you see for this one, the GUK ELM has a much better performance than all of them. So in conclusion, the kernel trick is utilized. The kernel trick is utilized to avert the troublesome problem of determining the optimal number of hidden layers in the standard ULM model. And after the global and the local structure feature information of the nonlinear observation data is extracted by the GUM model, the SVVD is adapted to derive a static for the fault detection. So we use the SVVD to derive the static detection. The simulation result, numerical nonlinear system and the benchmark series process manifest that the GLM-based method outperforms the KPCA and based on the EU standard and the methods significantly for monitoring the nonlinear process. Thank you.